Today, solar PV safety. I'm Tim Montague, your host. Welcome to SolarWorks for Illinois. Today, we're going to be diving into how solar arrays can be made more safe and what are some of the challenges to solar system safety. My guest is Lawrence Shaw, who is a solar engineer. He is the chief solar engineer with Higher Powered Solar, which specializes in project O&M and independent engineering. Welcome to SolarWorks for Illinois, Lawrence Shaw.
Thank you for having me, Tim.
Really a pleasure. I saw Tim Sylvia's story a couple months ago and had him on the show talking about some of your work. And it's great to get directly to the source now. You have taken an interest in solar PV safety, and obviously you make a living consulting in the O&M and as an independent engineer. But tell us a little bit about your background, how you got interested in renewable energy and particularly solar O&M and safety.
Sure. So my career in industry began 18 years ago as a nuclear electrician in the United States Navy. I was first introduced to solar specifically in 2012, thanks to a colleague who told me about this wonderful graduate program at Arizona State University. Specifically when it comes to operations and maintenance and fire safety, I came to realize that operations and maintenance, O&M, is a very critical piece of a project's life cycle that is not generally well contemplated during project development. And then, specifically with fire safety, I feel in general that it's kind of being ignored. I mean, sure, the stated purpose of National Electric Code is fire prevention, but distributed solar on the scale we're witnessing is something new altogether. The paradigm has changed. Instead of central power plants at far away where the end user doesn't have to think about it, we have moved the location of power generation to the end user location. Many times these folks wouldn't know there was a problem with the solar on the roof until it was too late.
Yes, solar is generally speaking out of sight, out of mind, and which is why it's so important that both the host or the owner are regularly monitoring the system to make sure that it's producing as anticipated, and also then nipping any problems in the bud. When solar arrays break for various and sundry reasons, and we're going to get into some of those issues that solar arrays face, it can be a benign break where it just shuts down or is underperforming, not producing as much electricity as it was designed and engineered for, but it can also be a safety issue, right? Solar arrays do catch fire. They can develop hot spots, which can then spark and actually catch a roof or an entire solar field on fire. I have a colleague in Arizona who's doing some repair work on a large solar farm, and 10,000 solar modules burned up in that fire. So while solar is, generally speaking, very safe and mature technology, it has been around for 70 years, as I say often. All modules are not created equal. There is a spectrum of quality. In the industry, we like to lean on the tier 1 list, but as I explored with Tristan at PVEL on the recent episode of SolarWorks for Illinois, where we dove into the scorecard that they produce each year, there are the tier 1 list is not a list of quality. It is more about bankability. So now, just to set the table a little bit, we're installing about 15 gigawatts of solar in the United States each year. That's about 37 million 400-watt solar modules. It's a huge number of solar modules and accompanying electronics and wires and switchgear. And so there's many, many points of failure, potential points of failure in these projects. But how did you get interested in solar O&M?
Sure. So a lot of that came from job experience. I, I was fortunate enough to work with the operations and maintenance of NRG's commercial solar fleet for a few years. And, in that time, I got exposed to how developers go through their decision-making process when they're developing projects. And, a lot of times, and I'm not actually really referencing any one company in particular, but a lot of times the O&M provider isn't talked to up front when a project's being developed. That they're the last person that gets involved in the discussion, when really they should be involved as early as possible so that they can say, okay, look, this is what it would really take to get a service technician to this site that's in this remote location, or on this rooftop with these materials based off of the weight of this inverter or the size of this inverter and so forth. And all of those logistical questions really go into what is the cost of operations and maintenance. And the cost of operations and maintenance really is one of the variables that dictates the overall cost and therefore profitability of a project. And so I just think it's a piece in industry that is really complex and not always paid credit for how complex it is. So that's why.
And why is fire safety a particular interest to you? You did quite a bit of research on the history of solar fires in the United States. Why is that of interest, and what did you find?
Sure. So it's of interest because basic engineering principles tell us all that this was going to be a problem. Conductors, there's thermal expansion and contraction. This happens in any electrical system. Over time, you will have loose connections. And loose connections can sometimes develop into hotspots. Solar is not just an electrical system, it's an electrical system that we have put into the sun where it is really hot during the day and sometimes maybe really cool in the evening. And so there is going to be thermal expansion and contraction. There are going to be loose connections that develop. That's what basic engineering tells us. And in fact, there are companies that are experiencing this where they're experiencing what they call thermal events. This data does not necessarily make its way to the U.S. Fire Administration. The U.S. Fire Administration publishes data that is publicly available. That's coming from states or local municipalities. And what that data is telling us is that there are an increasing number of fires from solar every year. In fact, for the most recent year published, which was 2018, there was a 36% increase from the prior year.
Yeah, as solar takes off, potential problems with solar takes off, and that's just the nature of the beast. The fact that the number of fires in this case is growing is not necessarily an indicator, though, that there's a problem with workmanship or even the technology. The sheer number of solar projects is growing very, very fast. We have over 2 million solar installations in the United States. What do you say to that?
Right. So, when you have a new installation, it's probably not going to, the problems aren't going to manifest in the first few years of operation, probably. In fact, in Japan, they had over 100 different fires. And when they looked at the root causes of those fires, it was for aging connections. So, yes, we're in a really big development cycle. Yes, we're installing a lot of capacity right now. That means that we're going to have a lot of problems later down the road.
Yep. And so tell us more about your research into solar safety. You mentioned the U.S. Fire Administration if there is a fire in the United States, what are the odds that the fire administration gets their hands on that data anyway?
So in terms of exact odds, I can't say. I can say, and there was an article by PV Magazine where they determined that a lot of fires weren't being represented. They were being just counted as other in terms of causation by probably it's a effect of a local reporting agency like a city or a town. Their fire department responds to a fire. They don't have solar as a potential problem in their drop-down list or on their standardized report template. So they just list it as other in terms of causation, and so it doesn't get counted. How many don't get counted is really a question mark.
Got it. But then some of the fires that occur do get characterized as being related to a solar array. And just tell us, what did you learn by studying the fire administration data?
So a few things. So there's an increasing trend. Again, that's 36% for the most recent year, 2018 relative to 2017. There is, this tends to happen a little bit more in the residential space versus non-residential. So that would be commercial and utility. And that would be kind of what we would expect or anticipate based off of utility and commercial have more rigorous maintenance practices and more rigorous control over the workmanship and the quality of parts being installed. The other thing that we are seeing it's unfortunate for me to report is that there was a 34 acre wildfire in Humboldt County, 2017, where the equipment power source was a solar system. And, I had a little bit of dialogue with the fire chief, and it sounded like that it was from the balance of system components. And one of the things that it was attributed to directly in the report was being unmaintained, poor installation and and being unmaintained. So that's what we've learned so far.
So there are many factors that can contribute to the overall reliability of a solar project. There's the equipment itself, there's the installation, then there's the operations and maintenance, how much O&M is being done. What do you recommend to homeowners and commercial industrial system owners in terms of an O&M regime?
Sure. So actually, for O&M, the first thing is for commercial owners as well as residential owners is to read the interconnection agreements, because I'm pretty comfortable with saying that in the interconnection agreement, they're going to find that maintenance, regular maintenance, is required by the utility company, and they've agreed to it already. The next thing is to, especially for residential system owners, is to ask their installer for a preventative maintenance plan that includes infrared imaging. And then, in general, especially I think that this may be a little bit more achievable in the commercial space, would be to collect field-based reliability data. And what I mean by that is when you're mobilized for maintenance activity, be it preventative or corrective in nature, use that mobilization as an opportunity to take additional measurements in the field with the system. Do a visual inspection of the panels. Look for any problems that may be occurring in the panels, even if you're there for an inverter outage. Those would be my general recommendations specific to maintenance.
Sure. And that's one of the messages I send on a regular basis now in my media is O&M is very important. You have to get an O&M contract if you're a system owner. And it could be with the original installer, it could be with a third party. And we ourselves at Continental are fast growing our O&M division because there's so much solar coming into Illinois. It doesn't matter if we build it or not, we want to do O&M on it. So reach out to me if you have a project that needs O&M. Let's talk about the NEC. The National Electric Code is driving the installation of, for example, module level power electronics, which in turn means that there are many more points of potential failure in a solar project. How do you see this playing out?
Sure. So, as you pointed out, this was this kind of a recent code addition. In fact, NFPA 70 2017, in the 2017 code book, it says not valid until January of 2019. So it's very recent. And as you said, with the added points of potential failures, how do we see that playing out? Well, it is an addition of points of failures, and basic engineering principles say that we will see more failures. There's also physics too behind this, even though the data isn't there yet. Physics is this. So in most module level electronics, I'm going to be general, many of them have the book-bust circuitry occurring in that microinverter or in that optimizer. Okay. And what that means is high frequency switching. Right? And high frequency switching means heat. And heat goes where? Goes up. That's just convection currents. Heat will go up. So you have put a heat generating device directly underneath a PV module. And all of that heat is going to go into the cell or a couple cells that module level electronic is underneath.
You mentioned thermal scanning or infrared scanning. Can those expressions be used interchangeably?
Sometimes they are, but formally, what you should be doing is using infrared imaging, and it needs to be with a camera that can tell you what the average cell temperature is for that PV module and what the hottest cell temperature is for that PV module, because the safety defect that you're looking for is 20 degrees Celsius relative to the average cell temperature.
So let's talk a little more about that. You have a thermal camera or an infrared camera. I say thermal just because it's easier. It rolls off my tongue easier. But when I say thermal, I mean infrared. And
I do too.
You're flying that camera with a drone or a pole even, and then taking photographs or images of the solar modules in a facility, whether it's a residential, commercial, industrial, utility scale. And then you're getting some information back. What are you seeing? What are you looking for? And how does this then translate into an O&M strategy?
Sure. I've encountered a lot of drone infrared camera companies that will give you their marketing material, and you will see on their brochure some really just great photos of a solar array, and you will be able to tell exactly which modules are off, which ones have hotspots, what portions of the array have an entire string impacted. And it's great from a visual standpoint of knowing where your problems are. But the thing is, when you're making operational decisions, some of those problems are just production issues and not safety issues. And it might not make sense to dispatch a service technician in a truck at $100 an hour to just go troubleshoot an offline string. You really need to be able to understand your priorities. And for that, you need to understand where your safety defects are. And for that, you need what I just mentioned, which is infrared imaging that tells you the hotspots, are they over 20 degrees Celsius relative to average cell temperature? That would be one PV module safety defect. And there are about there are actually at least 25 PV module safety PV module safety defects that have been defined in literature.
So infrared imaging is a great way to know what's going on with the array. What else can owners do to monitor what's going on with their array?
Sure. So smart combiners or string inverters with string level monitoring, current transformers. These are things that are known. It's usually often a cost trade-off decision. The developer will say, well, okay, how important is it for us to have string level monitoring when, you know, we should be able to detect problems when we're mobilized during a PM? So there are trade-offs there, like what level of granularity do you want in terms of monitoring your system? I mean, right now, actually one of the advantages of module level electronics that you brought up is that you get module level monitoring, which is actually pretty cool. I'm not necessarily an opponent of module level electronics, as long as there can be sufficient air gap.
You're saying create an air gap between the module electronic and the module.
Correct.
Yeah. And that makes a lot of sense. There's no reason why there can't be an air gap. It does depend on how much room you have between the roof or the ground and your module. So every situation is a little different, but and that module level monitoring is wonderful. I've used it myself. We have done some SolarEdge installations, and SolarEdge has a nice smartphone app, and then you can literally see down to the individual modules or pairs of modules what's working, what's not. And honestly, we, in our travels, we see various and sundry problems. We see problems with combiner boxes. We see problems with connectors. We see problems with junction boxes. Mm-hmm. There can also be micro cracks in the modules from transportation and handling. Workers putting solar modules on their heads, for example, is a big no-no because it can cause micro cracks. Can all of these problems, though, be triaged with thermal scanning? Is thermal scanning or infrared scanning a catch-all?
Sure. So there are actually, right now I am sort of, if you look at my LinkedIn posts, anytime there's a PV fire, I bring up infrared imaging. I do that because it's a really easy way to help people zone in on what will help them identify the defects. If you limit the discussion to PV modules, okay, there are 86 defects that have been defined in literature. 25 of these have been defined as safety defects. Those 25, you can catch all of them with a combination of visual and infrared imaging.
Yeah, in the recent PVAL report, they called out PID, potential induced degradation, as a major flaw. Is PID identifiable with infrared scanning?
If it is, I'm not familiar with that technique.
Okay. So, you have drilled down on solar fires. You seem to be convinced that one of the primary culprits is hotspots occurring on solar modules. Is that right?
So in terms of primary culprits, this goes back to the problems with the data that we have today, which is we know that there are solar there are fires where the equipment power source was solar. We don't know where in a solar system the faults are occurring, not quantitatively. Part of that is attributable to the local reporting agencies not having a way to subcategorize the fire's location. Okay, it's in the solar system, but was it in the solar panels, or was it in an inverter, or was it at, you know, the service panel, and so forth. Another part of the reason that we don't have the data is because our data collection efforts so far in industry have been geared towards understanding issues impacting revenue and not issues impacting safety. So a data acquisition system, for example, will probably be hooked up to an inverter. It'll probably be hooked up to a revenue meter, and it'll probably be hooked up to a weather station. And it could be hooked up to other parts of the system. Now, tabling module level electronics for the time being, a data acquisition system is probably not hooked up to the PV modules. So it's not going to tell you that you have problems in the PV modules. So if you don't have any measurements saying that you have the problems, then how do you know the number of problems that there are? Okay, you follow me? So that's what I attribute the missing data to. So when I say hotspots, I'm not saying definitively that's where all the problems are. I'm wanting to elevate the need for infrared imaging as well as visual inspections, because the two combined, if they're being done formally and there's a way to collect the data, will give us the data of where the problems are occurring.
Mm-hmm. And it seems to me like there would be a useful metric looking at what kind of data you're collecting year over year. So if you see X number of problems in, you know, year 5, but then you see X plus 10 problems in year 7, then you know that you've got a trend, and maybe you could take some corrective action. Yeah. Let's talk a little more about hotspots, though. What exactly is a hotspot? What causes them? And how can they be detected and prevented?
So, you know, again, from a in terms of the physical mechanisms that cause a hotspot, I would say that they vary, right? You could have a cell with some imperfect material properties, and for whatever reason it didn't want to pass current through it. That could be a outcome of the a defect in the silicon itself. It could be a problem with the metal fingers that are meant to collect the electrons. It could be a soldering connection. It could be a problem with high resistance coming from one of the layers in the PV module itself. There are many different mechanisms that could be the cause. And in fact, I think that's a great question for a lab, and solar PTL in Arizona would be the first place that I'd start. In terms of detection, again, that visual inspection and the infrared imaging. In terms of prevention, again, what you were alluding to, which is if we're collecting data over time and we see X number of particular events in a year, and we identify a trend, then we can identify strategies to address that trend.
Yep. So a hotspot is someplace in the module where electrons want to flow and cannot flow, and so they're heating up. And yes, a hotspot starts small but can grow over time, and so the risk of that in an individual hotspot presents will potentially grow over time. Is that right?
Correct. And from a safety perspective, again, it's 20 degrees Celsius relative to average cell temperature.
Explain that. I don't quite follow.
So when you take an infrared camera and you look at a specific region with that camera, it'll tell you the average temperature, well, if it's of a certain quality, that camera itself. It can tell you the average temperature in the, sample area. And it can also tell you highs and lows. So what you're looking for is you're looking for a high that is 20 degrees more than the average. And you want your field of view to be that one PV module.
Okay.
Yeah, actually, Arizona State University's Photovoltaic Reliability Laboratory published a great paper, and that's where you would find the 25 PV module safety defects.
And that again is the Arizona State PV
Photovoltaic Reliability Laboratory.
Okay. Arizona State in Phoenix?
That laboratory physically is located on the Mesa campus.
Okay. Mesa, Arizona. Okay, great. So why do you think the industry is a little slow to adopt more rigorous preventative maintenance of solar projects?
This is speculation. I'm going to be upfront with that. But I think at the end of the day, utility companies and insurance companies are more interested in shedding their own risk than protecting consumers. Utility companies now no longer with solar systems have to take care of or maintain the equipment or be liable if there's a fire. And so they simply say, you, the off-taker, must maintain this system. And by the way, that's often true, even if you're leasing the system. Insurance companies know that by and large, nobody's policing this. And so they know the maintenance, upkeep maintenance isn't being done. And so if there is a fire where it's big and a fire department spends millions of dollars fighting the fire and there's an insurance claim, nobody's going to be able to prove to the insurance company that the maintenance was being done because by and large, upkeep maintenance isn't being done in the residential space.
Mm-hmm.
And then in terms of industry overall, we're under enormous pressure to bring costs down. And part of that, I believe, is because people's hearts are in the right place. They want to fight climate change. They want to keep carbon out of the atmosphere. And so they want solar to be more cost competitive so that it's deployed on the scales that you were talking about. I think you said 15 gigawatts in the pipeline. The thing is, if we don't be deliberate in our fire prevention, then we're going to put carbon back into the atmosphere. And that's the part that I can't abide by.
I don't quite follow. You're saying if we don't do O&M right, then solar is going to be less popular?
No, we put carbon back in the atmosphere. I mean, the wildfire in Humboldt County, 34 acres, all that smoke, that's a lot of carbon to put back in the atmosphere all at once.
Mm-hmm. Not to mention all the human safety issues, right? I mean, literally life and limb are at risk in any kind of a fire. So it's just it's not good for humanity, not good for the industry. What else would you like our listeners to know, Lawrence?
That's a good question. Really, I think in general, I mean, one of the things that I don't think we've touched base on is the importance of specification up front. Operations and maintenance is really a piece of this, and it's what I'm trying to champion. But another piece of this is proper specification of a system upfront. For example, I attended the roundtable discussion hosted by PV Magazine at the 2019 Solar Energy International and in Salt Lake City. And at the roundtable, one of the case studies talked about for fires was a ground mount system. And that system had fires that were coming from 3 of the 4 types of PV modules that were installed. Now, the make and model of those 4 different types of PV modules was all the same. But the bill of materials, there was actually 4 different bill of materials used for those PV modules. And the only one that wasn't causing the fires was the one that had the bill of materials that was the same bill of materials used during the IEC 61215 certification. And especially at the utility and commercial level, when you have that kind of buying power, when you're buying, say, 6,000, 7,000 PV modules, you can say to the manufacturer, okay, we're only going to get modules that have the same bill of materials that was used during the certification. Mm-hmm. But that all goes to proper system specification. And so I would say the specification is something that everybody has the right to. Even if you're a homeowner, you have the right to say to your installer, hey, look, you're going to use stuff that is UL certified, stuff that is IEC certified. And I don't think that in general consumers have a good, at least in the residential space, a good resource for like, hey, what would be reasonable things for us to require our installer to do? And so I actually, when I was getting ready for this call, that occurred to me, and I'm going to be putting an article on LinkedIn where I'm just going to share my specification that I would use for a residential system. And I'm going to share all the rationale of why I do certain things. And it's going to be publicly available, and people, can take it or leave it as they wish.
Wonderful. Well, that brings me to my last question. How do people find you?
Right now, LinkedIn is probably the fastest, surest thing. All of my contact information is there. So if people want to get a hold of me, that's a good way to go.
And you can find all of our content for SolarWorks for Illinois at cesnrg.com/podcast. Check us out on YouTube. Please subscribe to our channel. Give us a thumbs up. Tell your friends about SolarWorks for Illinois. I'm Tim Montague, your host. Thank you, Lawrence Shaw, for enlightening us on solar PV safety.